Have you ever seen a fireworks show? Then you've seen a small-scale version of a supernova explosion. You might think that all stars explode in the same way, but not all do. But Type 1 stars don't. Instead, they explode as a result of a thermonuclear reaction. We'll talk about both types, starting with Type 2. In this video, we'll look at what happens when a star goes supernova. Let's dive in. As a star gets older, its core gets denser, and its outer layers get bigger. Eventually, the core is squeezed so tightly that it can no longer undergo nuclear fusion. Unlike Type 2 stars, Type 1 stars don't collapse during a supernova explosion. Instead, they explode as a result of a thermonuclear reaction. Here's how that works. Stars like our Sun have hydrogen-burning cores and helium-burning shells. As a star ages, its core contracts, which increases the temperature and pressure in its helium-burning shell. The amazing science that happens around us every day is something to celebrate. When the pressure and temperature become great enough, the helium in the shell undergoes nuclear fusion and ignites. This causes the star to expand rapidly. The outer layers drift away into space, and the star is said to go supernova. At that point, the star's core collapses under its own gravity and hits the floor. Like literally, it hits the floor. In some cases, the explosion of a Type 1 supernova can be so powerful that it blows both stars away. Because it was so close, the explosion gave us an incredible amount of information about these amazing astronomical events. They can be used to measure distances within the universe. By studying the light from a supernova, astronomers can determine how far away it is. This allows them to use the universe like a giant map to measure the distances between galaxies. For example, the explosion showed that supernovae release an enormous amount of energy. Just one supernova can outshine an entire galaxy for a brief period of time. They also showed that supernovae are highly variable. Some last only a few weeks, and others last for months. If that happens, the remaining matter can form a disk around the binary system's point of mass. Over time, the matter in the disk can cool and solidify, forming a thin, flat object called a diskette. Sounds familiar? Well, that's because diskettes are the building blocks of planets. So one day there may be a solar system where the planets formed from the debris of a supernova explosion. It smashes into the star's lower atmosphere, which is made up of mostly hydrogen. The heat from the impact ignites the hydrogen, causing an explosion. This is similar to a bomb made of Hindenburg, except a lot more deadly. The explosion blasts the star's atmosphere into space, and the star is said to go supernova. There are two main types of supernova explosions, Type 1 and Type 2. Type 2 stars have enough mass for their cores to collapse. For example, if the star was between 8 and 20 times larger than our Sun, its atmosphere would carry away all the angular momentum. The star would collapse further and bounce back. Some of the atmosphere would fall back onto the star and reignite, leading to another explosion. This cycle could repeat several times until all the star's atmosphere is blown away. What's left behind is a small, dense ball of matter called a neutron star. Neutron stars can be incredibly massive. A teaspoon of material from one would weigh billions of pounds. Stars produce energy by fusing hydrogen into helium in their cores. What happens next depends on how much mass the star had before it exploded. If the star was even more massive before it exploded, a black hole could form instead of a neutron star. Black holes can't be observed directly because nothing, not even light, can escape their gravity. But scientists can observe the effects that black holes have on other objects. For example, a black hole's gravity can heat nearby gas to millions of degrees. That gas emits X-rays that can be detected on Earth. Scientists also know that black holes can spin because in 2004, an international team of astronomers captured an image of the first black hole ever found. The image was taken with a radio telescope and shows gas emitting light as it orbits a black hole 5,000 light-years away. Now let's talk about Type 1 stars. Some Type 1 supernova occur in binary systems, meaning they consist of two stars orbiting each other. In 1987, a supernova explosion occurred in a nearby spiral galaxy. It was the closest one that humans had ever seen. Supernovae are important to astronomers for another reason. Well, that's all for this video. But before you go, I want to remind you to stay curious. I hope you learned something new today. If you did, please like and share. Thanks for watching. I will see you in the next video.